Hey everybody, welcome to TechKnow Tuesdays. I'm Phil.
I'm Kevin.
And I'm Kendrick.
Hey, so Kendrick, what's up this week?
All right, so I was browsing the FTC forums the other day, and I'm going to provide you guys with some important information. It's like information.
Oh, information?
But with the forum.
That's not funny, Kendrick.
Yeah, it's pretty lame actually.
So there are a lot of common questions that are asked like over and over and over again, and nobody seems to read through the forum questions before they post a question, because there's multiple instances where there's like 5 or 6 questions that all ask the exact same thing. One of which is like,
give me an example, Kendrick.
grappling hooks seems to be a big thing this year. A lot of teams have posted on the forums asking questions about if they can launch a grappling hook to grab onto the mountain. Some want to use CO2 canisters, others want to use some high-powered springs.
Doesn't sound legal.
Right.
Didn't we talk about this last time, Kendrick? A week ago, didn't we discuss this whole launching issue? And it's still going on, eh?
Right. So
There's no one listening to us.
So it's in the rule book. It's it's definitely illegal to launch any part of your robot.
I think it actually says it is not permitted to launch any part of your robot. I think it's that specific,
Right.
isn't
And
it?
what rule is that? Do you remember?
GS11?
GS11?
RG11.
RG11?
G11. It's 11. It's in manual number 1. It's easy. Do what I did. Open up the document, search for the word launch. It's the first time it comes up.
And then, okay, so along the same lines of the CO2 canister, you're not allowed to use pneumatics or
Right.
compressed
Any compressed anything.
compressed fluid.
Yeah.
And so along
Including
the same lines,
tires. Including tires.
right. So speaking of which,
Oh, I see. Did I preempt you there?
so there were 5 or 6 more posts, people asking if they can use air-filled tires, asking if they could use tubeless tires if they're pneumatic tires, and then there's people asking if they can use shock absorbers and that sort of thing. All of which, of course, are illegal because they all use
Pneumatic.
compressed fluids, and so yeah. And then on the subject of tires, lots of teams have been posting specific links to specific tires,
Right.
asking the forums,
Are
they legal? And so in the very first post, the response to that was, well, we can't specifically rule out any specific wheels, but we're going to say that if it's marked as high traction, that's illegal.
Oh, really?
Or if it's
Whoa.
or during inspection, the inspectors may ask the team to run their robot against the wall, and if the wheels or tracks cause damage to the field, then it's not going to pass inspection.
Well, that sounds kind of familiar. Have you
Yeah.
ever had
Yeah.
that happen to you guys?
Yeah, we had that
Maybe.
happen. Whenever we use the Andymark high traction wheels.
Yeah, we don't know this for a
that
fact, but we
happened.
suspect these guys caused the part to become illegal.
Yeah. The part and the rule.
And the rule.
Yeah,
Right.
autonomous, the robot just kind of like took off, hit the wall, and kept it running.
Right.
Tore it up pretty bad.
So the real question is then, what are they going to consider damage? I mean, scraping the surface. I mean, is that damage? I would hope not. I mean, tearing a rip in the surface, I would assume that would be damage. But if it's like, oh, look, it left a mark. Like, I'm sorry, guys. People walking on the field leave marks.
Right. So if it were me ruling it, that's probably the exact same way I'd rule it is,
But it's at the
If
judge's
it-
discretion.
If it's tearing up pieces of the field, that's a no-go. If it's just causing a little color change in the tile, I'd say no biggie, as long as it doesn't tear up the field.
Well, you probably end up getting that color change anyways, even with the stock
Right.
wheels. I'm sure you could get.
Oh,
it.
yeah. I mean, it's hard to run any wheel on those floors without leaving a physical mark. But, yeah, let's hope it requires actual damage, not just cosmetic damage. There is a lot of variability in how judges call that, or referees call that.
Right.
We need a probably photo thing. Does it look as bad as this, or does it look worse than that? Something like that.
Speaking of photos,
Oh man.
photographs.
So I was browsing around today and I found this camera called the Seek Thermal. It's pretty cool. It plugs into either iOS device or Android, and it's just a thermal camera. It's pretty cool.
So this is like real thermal imaging, though,
Yeah.
not like those fake apps that pretend to do thermal imaging.
Yeah, those.
So what would you use it for, Kevin?
Oh, you could use it for hunting, for checking the temperature of your engine without burning your hand off. There's a lot. There's a good many uses for a thermal camera. It's fairly inexpensive too. It's like $160.
So what sort of temperature range can it do?
It can do anywhere between -40 to positive 330 Fahrenheit.
Fahrenheit, I see.
Fahrenheit.
Okay.
And I'm guessing that that's not like full HD video.
I take that back. It is Celsius,
Okay.
Okay.
which is quite a good range.
But it's not
What?
HD video?
No, it's not. It is actually. Let me check here. Make sure I get this right, because it's not a standard resolution. It is 206 by 156.
Oh, that sounds like my first digital camera I ever had about 30 years
Yeah.
ago. But I mean, that's normal. I mean, yeah, that's pretty cool. I mean,
Yeah.
that means you could, if you're up close, you could get a pretty good
I mean,
view
Picture
of
of it.
something.
that's
Yeah.
going to be one of the ways that they get the price down
Yeah.
low enough to be reasonable is.
And its view range is like 36 degrees, so it's not a wide angle camera.
Right,
at
but it's
all.
like if you wanted to use it like me, I'm into energy efficiency, so you could use it to look for cold and hot spots in the walls of your house from the inside and the outside. That'd be kind of cool.
That would be pretty cool.
So how soon are we going to be seeing the 4K thermal imaging cameras?
Ooh, not a long time. Well, you know, it
Not
depends how
that
much
are-
money you got.
Not that are $160.
Yeah, it sounds more like a $10,000 or $12,000 camera.
Yeah.
Yeah, pretty cool.
Phil, what have you got for
I
us?
was anyone going to ask me what I want to talk about today?
Nope.
No, we're done. Bye.
Okay. All right. So today I want to talk about state machines, and the reason I want to talk about state machines is I've just spent the last 4 days making a 3-part tutorial video all about state machines, and so like get that plug out there. So a state machine, in case you don't know, is a programming technique that's used for dealing with complicated random event kind of situations inside a program. So a normal program you might write, you know, in sequence, and it does this, and it does that, and if it does this, it does that, and one after the other. Whereas a state machine assumes that your program is in a specific state at any time, and while it's in that state, it's doing a specific function, and then all of a sudden an event happens which causes it to go from that state to another state. For example, this morning, I was working at my computer, doing my videos, so I was in the video editing state, and then an event happened. The phone rang. It's these guys going, "Where are you?" And it's like, oh my. So then I changed my state to TechKnow Tuesday state, and the thing that's compatible with programming is that at the point where I changed that state from video editing to TechKnow Tuesday, it took an action to do that, and the action was getting in my truck and driving here. So that's what state programming is, state diagrams, state machines are all about. And so it's relevant for FIRST because this year when they first brought out the STK for FTC, there was this loop function that everything you did had to be done in this little loop function, but you couldn't stay in there for very long. So one way to deal with that is to create a state machine that remembers what it was doing last time it was run, and the program comes in, you look at your state, you say, are there any events that I need to deal with? If not, do this action, and then leave. And so it's a pretty cool thing. Now, it's not necessary anymore with FTC because they also created this new linear op mode. But I think state machines are a really cool, valuable programming tool. I've used it all throughout my career.
So, question.
Yes.
If you had an if statement, just a single if statement, would that be a state machine?
No, because the whole purpose of a state machine is remembering what you're doing last time. So if you're just coming in, you know, for an example, it might be tracking a line. If you're coming in, looking at the line, taking it action, and doing it, that is a state. Taking that action, doing that is one state. So that's not a state machine. That's just a program running all the time, one state.
Okay.
A state machine would be remembering what you're doing. So what I did is I created an example autonomous routine for FTC where you go across, you navigate across the field, you find the white line, you find the wall, you don't worry about the beacon, you put the climber in, then you back out, then you get to the mountain, then you climb up the mountain, and I put that together as a state machine. It's a fairly linear state machine because there's like 8 states that just one after the other, but it's designed as a state machine, so it's got a list of states and a big switch statement that handles each one, does the event transition to basically show how it can be done. So the tutorial's got explanation of state machines, how to do a state transition diagram to design your program, and then a walk through the code that actually does it.
And is that on YouTube now?
It will be very shortly.
Okay.
It's all up there, but I don't have my cross linkages.
Okay. Darn, I was gonna have Kendrick put a link.
We could put it right here, perhaps, right here, a link, because it is a YouTube. Okay,
so it's a YouTube video,
right here.
so we can do that.
That's right. There's a link. All right, cool.
We've learned.
But check it out, because even if you don't need it for this time around, state machines you'll use all the time,
right?
Because they can be very elaborate. They can deal with very complicated situations without being hugely complicated. That's the beauty of them. You do the diagram, and then you add lines. You can say, well, what happens if this? Well, let's add a new transition. Let's add a new state. It's very easy to expand on a complicated program.
Cool.
Right. Which makes it a kind of extra good way of doing the programming for FTC this year. It's like, not only are you learning it for FTC and giving you a slight advantage in FTC, but it's something used in the real world every day.
Yeah, all the time. All the time.
All right. Is that it?
I don't know.
That's all we got?
No, I was going to talk about judging.
Judging.
You see, I have my you probably can't see. I have my Baja design judge shirt on today, and I just wanted to mention that for anyone who's out there, maybe on a team or maybe coaching a team or maybe just hanging around, there's more to the competitions than just competing. There's the whole volunteering, the judging, and I find it a lot of fun to be a volunteer judge at different competitions. Not just robotics competitions, but a little while back I got to be a design judge at a mini Baja competition. And it was pretty cool because it was a whole different side of engineering that I hadn't been exposed to before, the whole vehicle dynamics and all sorts of stuff like that. And it was good as a person for me to see that growth in myself, but then also to be able to help kids understand a new form of engineering, new form of design. So it's pretty neat.
Were you a good judge?
I hope so. I wasn't an evil judge, I don't think.
You don't think you were one of the tough judges that was like, oh, they stumbled on that word a little bit. Let's knock that down.
No, but it was funny because there were some areas where I was a little out of my depth in terms of the technology side of it. I mean, the whole engineering process, which is what it was all about, I could deal with without any trouble. But when they start talking about the dynamics of the bump steering and the camber and the cast and all that sort of stuff, it's like, and I'd ask a question and they'd answer me. And I wouldn't necessarily know whether they were telling me the right answer or not. But then they get all defensive, like, that's right, isn't it? And it's like, well, I can't tell you that because I didn't know. So it was kind of cool.
Play it cool.
Play it cool, exactly.
I'm not
Then you lean over, hey,
authorized to
other
give you that
judge.
information.
But the beauty of that competition is that we weren't judging whether they were right or wrong. What we were judging is, had they gone through the engineering process? Had they identified a problem? Had they decided what they wanted to do specifically? It wasn't enough for them to say, well, we wanted to make our car lighter. They had to say, we wanted to make it like 12 pounds lighter. And then how did you go about deciding that? How did you verify that it would be mechanically sound? Did you do it, and then did you test it afterwards? So whether it was a right decision or not was kind of irrelevant. It was had they gone through the process, and could they show us the data, and could they show us the results, and had they drawn the correct conclusions from their data. So I could do that. Yeah. I could verify whether they'd done that or not, even if I didn't understand whether they'd done it right or wrong. Yeah.
It wasn't just we needed our Baja car to be 12 pounds lighter. Well, why did you need it to be 12 pounds lighter?
Because
we don't really know.
Yeah, exactly.
We just wanted it.
Because the driver gained weight over the summer.
There are a lot of teams, the junior teams, that would say, well, because we needed to go faster, because we needed this or we needed that, and they just knew intuitively what they wanted to do, but they didn't really know engineering-wise they wanted to do it. And that's what this competition is really judging. The elite teams have all that data. They know what they're doing. They know their goals. They've got specific design things they want to change, and they'll set up a dynamic testing jig, or they'll set up some road tests, and they'll instrument their vehicle, and they'll take the data, and they'll plot it out, and they'll look at it, and they'll say, well, did we get what we wanted to get? They're the teams that get to the top. They're the teams that win.
More real-world learning.
Yeah. It's more disciplined, but what you get out of it at the end. And the really cool thing is that the Baja is sponsored by Polaris, and so those guys are hunting out future employees, future engineers, future whatever. So a lot of the judges that were there were past competitors that now work for Polaris. So it's pretty cool. Or working for car manufacturers, or working for other places around that had their beginnings in the Baja. So it clearly it really is a proving ground for them.
Yeah, seems really useful.
Yeah. All right.
Yep.
Now I'm done.
All right.
Okay, I think we're
all right.
done.
So that's us. That's it for all of us. See you next week.
See ya.
Bye.